Um, Welcome to Mad Scientists, by the way. Today we will be focusing on all those like tiny, smaller experiments that we can't always do in a full to cover a whole 45 minutes or an hour. And it's just a bunch of smaller side experiments that are really fun to watch, really fun to do, but maybe only take 10 minutes or 15 minutes. All of these are great things to do at home. There's one exception that maybe takes a little bit of extra steps, but you already have probably all of this stuff at home to begin with. So, our first one is we're going to crush these cans. Now, we're not going to crush them with our hands by like just smashing them. What we're going to do is we are going to crush them with air pressure. You might ask how we're going to do that because right now these cans are under air pressure, right? But they're not crushed. They're not collapsing within themselves. So what we're going to do is we're going to use the fact that hot air expands and cold air shrinks. So what we're going to do is we're going to put these on a hot plate. Alternatively, if you have some boiling water from like a tea kettle or something, you can add those. You can just add some boiling water into a can. But these just have a little bit of water in them, and we're gonna heat that water up. So we're gonna let that go for a second. And in the meantime, we're going to talk about a couple other things. So this one, still cooling. So we're going to save that one towards the end. Okay, so here we have an egg. We have a hard-boiled egg. I'm going to bring this a little closer. So we have a hard-boiled egg and a glass container. You can really use anything. You can use a glass bottle. You can use a plastic bottle. Really anything will work with this experiment. But the trick is, right, I can't push this egg in here. It would break. But what I can do is I can suck it in there using science. So what we're going to do is, again, we're using air pressure. And actually, now that I think about it, 3 of our 4 things today are air pressure. Maybe that's our theme. Plus a bonus experiment. There we go, air pressure. So what I'm going to do is I'm going to light this little piece of cardboard on fire, get it going, and then once it's on fire, I'm going to put it in here, and then I'm going to place the egg right on top to make a seal. So once it's in there, I'm going to then, like I said, oh, it's kind of dancing. There we go. And egg is now inside. There you go. We have an egg inside. And it's kind of stretched and elongated now. I'm going to do this again over here with this other one. Hopefully you'll be able to see this one a little bit better. So again, we're just taking a piece of cardboard, lighting it on fire. And in fact, you can't see this. I'm going to move back just a smidge. There we go. That's still smoking. So cardboard. Again, if you're using fire, please ask a parent for help. Cardboard goes in. Egg goes on top. Oh, it kind of dances, which is cool. And then there we go. Oh, that one suctioned the egg in half. Oh my goodness. So that's the force, that's the power behind this, right? You can see the egg is completely like ripped apart in there. So that's all from air pressure. So what has happened is the piece of cardboard that we put in there starts to, since it's burning, as it burns, it's consuming oxygen. And then it's also producing carbon dioxide. And it's producing water vapor. So the water vapor and carbon dioxide, because the water turns to a liquid, because that's the case, it condenses. And that means the volume of gas that was in here is smaller than what was there before. So what has happened is, since there's not as much stuff in here anymore, the air pressure that is on the outside, which was normal, that has that same amount that we started with, now really wants to get in here. There's a saying that says nature abhors a vacuum, which means in nature, if there's ever a vacuum, it hates it. It wants to get rid of it. It has no interest in keeping it around. So it does everything it can to get rid of it. So that air pressure is all piled and collapsed on top of our squishy egg. And as that's happening, the air pressure is pushing and pushing and pushing, trying to get in there, because there's a mini vacuum in here created by burning fire. So because of that, it pushes and pushes, and it draws that egg down into it. Now, the way we're going to get it out is using the same method. This one is not coming out like this. This one we can just pour out probably, because it exploded. We're not going to do that right now. But the other one, the egg is completely intact. You can see there's some little burnt marks from the cardboard, but that's about it. I can get the cardboard out of there. So the way we get this out, right, if I just turn this upside down, our egg is stuck. And no matter how much I jiggle it, I'm not going to be able to get it out. So what I'm going to do is I'm going to hold this over some boiling water. And what's going to happen is it's going to heat up. And as the air in here heats up, it is going to do the opposite. So when we had the cardboard in there, it was consuming the oxygen and creating a vacuum. What we're going to do is we're going to heat up the air that's inside here, which is now just normal air pressure, right? And when we do that, we're going to heat it up, and it's going to expand, because gases expand when heated. And as it expands, it is going to create a pressure behind the egg, and it's going to be able to squeeze that egg out. So that's our goal today, our one for this project. So I have some water heating. This might not be hot enough. We might need to wait a little bit. Let's check in on our cans. I'm seeing some steam coming out of them up top, so that's good. That means we're probably ready. We can test one of them. So what I have here is just a pie pan with water and ice cubes. So what this is going to do is, this is cold water. So what we're going to do is, remember, we're heating up the water inside the cans, so it's really hot. So just like how we get out the egg, we're going to experience something similar. So this is going to get really hot, and right now, since the tab is open, the hot air can go out, and it can be replaced by cold air, because hot air rises. So the hot air, or steam, rises out, and then the cold air comes in, and it keeps this balance, so it's not collapsing in itself. But if we take one of these cans and turn it upside down inside of this water, and this might make a mess. I should have gotten a bigger bowl. But if you're not making a mess, are you really doing science? So what we're going to do is we're going to take this, turn it upside down. All of that hot air isn't going to be able to go anywhere. But the coldness of this is going to make the water, and that water vapor that is that hot air inside the can, cool down really, really fast. And when that happens, it goes from a gas, because it's steam, to a to a liquid, which is way more compressed. And that's going to reduce the volume that is inside these cans of air. So the air volume is going to reduce, and it's going to leave behind kind of a vacuum. And same thing again, when we create a vacuum, that air pressure is pushing on it at all sides, and it's going to collapse and crunch this can, because it has all that force from the air pressure, which is really weird to think about, because right now we experience air pressure, right? And we're not oh God, it's so heavy, we're not getting crushed. But we are feeling the air pressure at all times. And it's just something that we have grown accustomed to, is our air pressure. On other planets, the air pressure and really the gravity are different, so we might experience things a little bit differently. Air pressure does not keep us on Earth, I should say that. It is the gravity of it. Okay. Of Earth that keeps us locked on here. Okay, so I hear these boiling, so I'm going to grab one of these and get ready to flip it. So here's one. Here we go. And the first one, I was afraid these cans might be too tall for this. And maybe not hot enough. Oh, I think I was hearing a different can. I don't think this one was boiled all the way. We'll try this, and maybe less water. I think I need less water. In fact, this one has less water. We're gonna let these go for a little bit. We need them to be a little warmer, I think. And this one is starting to produce steam. Maybe it's enough. Let's see. To get our egg out of here. There we go. Is this enough? Yeah, I think this will be enough. We just need a little bit of the steam. And we need a good seal around the egg. You know what? I think we need a full boil. So we're not there yet either. Okay, so our next thing that we're going to talk about, and we're going to let these continue to boil. I definitely hear them boiling, so that's good. So the next thing is kind of a magic trick, or at least it looks like a magic trick, because magic is really just science if you don't know what's going on. Okay, so in this water bottle, I have a soy sauce package. And if I think about it really hard, I can make it sink. I'll do that up to the close-up camera, too. So again, soy sauce package. I'm going to think about it really hard. Oh, I can make it sink. Really hard. Think about sinking, think about sinking. Oh, and it just works. Okay. I'm not thinking about sinking. What was really going on is I'm squeezing the outside of the bottle. So the soy sauce packet, if you look closely, there's an air bubble in here. And that air bubble experiences air pressure. So right now, we have a water bottle completely filled with water. And you can absolutely do this at home. I did find out that the Taco Bell sauce packets don't work. So, but like ketchup packets or soy sauce packets, almost any kind of like pre-packaged little sauce will have a little air bubble in it. So that air bubble can be compressed. And when it's compressed, it gets smaller. And it's not able to keep the soy sauce packet floating anymore. So when I squeeze it, we're compressing the air, and it makes it sink right to the bottom. So all I have to do is squeeze it up and down. I believe, and I don't know a lot about this, so I'd have to look up more info, but I believe scuba divers use this. This relates to buoyancy, and they have to be concerned and aware that this is something that happens, and when you get deeper, air compresses. So when you dive too deeply, you have to be worried about the air compressing in your suit and your tanks and all that stuff. But it's a really fun magic trick that you can do with your friends. Okay. We have one of these bottles really going. So I want to try this again, one of these cans. So we're going to just take this and quickly flip it upside down. There we go. All right. So I think we just need a little bit. And it's actually full of water right now. It sucked up a lot of that water right into it. So again, oops. All I did, you can see it's completely crushed. All I did was put some boiling water in there and turned it upside down into cold water. And that temperature change, and I think more ice would have made this go a little faster, but the temperature change is really what condenses that vapor that was filling this up and causes that pressure change. Okay, it's looking like our water is looking good. So what I'm going to do is I'm going to make sure we have a good seal around our egg, and I'm going to put it over the steam here. And it's kind of tricky to get a good seal. So we're just going to hold this over our steam until it starts to push through a little bit. Maybe you can see this on the close-up cam. So we're just holding this, and it's going to slowly start to make its way through the top here. And then once it is all the way through, like once it has a good seal on its own, then what we can do is we can just put it in the water bath. But it has to be able to stay in the neck all by itself before we can do that. We're getting close. It's definitely made some progress through here, I can see. So again, this is just air pressure, right? We're heating up the air inside, and it's expanding. And because it's expanding, it's pushing that egg out. In fact, yep, there we go. So now this part will go a little bit faster. And here it comes. Here comes the egg. Just oozing on out of there. There we go. And that's how you get an egg out of a bottle. You can see it's all like elongated now and funky. Oops. There we go. So we have an elongated egg because we can wash this off. All it is like some charcoal from the cardboard. And there we go. We have our regular old hard-boiled egg. Because I love the sound so much, we might do this again. But I think, what's this guy doing? Yeah, that guy's doing pretty well. All right, so we're going to do one more can crush. I'm going to try to do this a little closer. So here, it has pulled up some water, and so it didn't crush it. So I can feel it. The water is about halfway. It's about right here, filled with water. You can see there was almost no water before. And what has happened here is we did not have it cold enough. So we're going to add a little, we're going to put this back on the burner. And I'm going to go grab some more ice cubes. Okay, so we need some more ice cubes. We warmed it up a little bit too much. Tootie, are you here today? Okay, there we go. There's my ice. We'll let this cool down. We'll let that heat up. And before we do one of our last experiments, I kind of want to do the egg again. Just because I think it's so cool. And something else that's happening is when there's fire on the cardboard, the hot air is rising out of this. And as it rises, it makes the egg dance a little bit and kind of bounce around, which I thought was pretty cool. Okay, So there we go. So that goes in. Egg on top. Dancing egg on top. And then boop! And because it's skinnier, that actually was a lot easier. I'm just going to get this out of there. And again, I want to see if we can. We're going to get the egg to escape by heating up the gas on the inside, which is now smoke right now, which is going to be an interesting effect. But smoke can still be heated. So we're just going to let this steam get hotter and hotter, increasing the temperature, thus increasing the volume that the gas takes up, because when gas gets hot, it expands. You know what? We have some of this like black char stuff that's making it so it can't get a good seal. I'm gonna wash my egg inside there. Woo. And that water is going to add to the ability to push out this egg as well, because that water is going to increase in temperature, as well as the gas, and expand. So our last experiment is something that we've done before on this series, but I just wanted to do it again because last time we kind of missed it. I can talk about this while our egg heats up. So this coming experiment, this last experiment that we're going to do, is sodium acetate. And sodium acetate is made when you combine vinegar, which is acetic acid, and baking soda, sodium bicarbonate. So when you combine those two things, you create, amongst other things, woo! There we go. There's our egg. Popped right out of there. And it's getting kind of squishy. But, so sodium acetate combines with, sodium bicarbonate and acetic acid combine to make carbon dioxide. That's the bubbling when you mix baking soda and vinegar. And then it also creates water, and it creates sodium acetate. Sorry, I completely forgot the word there. It also creates sodium acetate. So sodium acetate is very soluble in water. And because it's so soluble in water, you can dissolve a lot of it. So I have a lot of sodium acetate dissolved in water right here. And it's still pretty warm, but because I can dissolve so much of it, when it cools down, it will go through a crystallization process really, really fast. So, we're going to... Actually, we have an ice bath. Maybe we'll use that to our advantage after we do our last thing. But we're going to be able to watch it crystallize in real time. We are done with this egg. If anybody has any questions, feel free to ask. We're just waiting on things to heat up and cool down. Heat up and cool down. Definitely, if you're using a hot plate or boiling anything, absolutely get some parents' help with it. Because things are hot, and hot things are dangerous because they can burn you. So let's feel this out. Okay. So you can see we have a clear solution. We're going to angle this down. And the reason I want you to watch carefully because, in fact, can the main camera see this? It cannot. Okay. We're just going to cool it down just a smidge. We don't want to form crystals here because we want to form them when we can see them. Okay. I don't want to agitate this too much. So what we're going to do is I have some crystals of sodium acetate here. This is still getting hot. Okay. So what I'm going to do is I'm going to bring around our close-up camera to be a little closer. There we go. Now we can see things a little better. Okay, so now I'm going to just drop some crystals in here. And if it's ready to crystallize, it will. And if it's not, oh, it's going. You can see those crystals slowly starting to grow. Oh, so slowly. In fact, I'm going to bring this because it's going slow enough. You can see those crystals starting to form along the bottom there. If you can see it down the base. So we're starting to form those crystals and they're growing more and more. This is also an example of an exothermic reaction because when it happens, I'm going to shake it up to agitate it a little bit. There we go. It's starting to really grow those crystals. And it needs to cool down a little bit before it's like all the way ready to crystallize. It's still a little warm. But those crystals sprouted from our original set of crystals. So we only added a small little drop, little like fragment of crystals, and now we have a whole bunch of crystals. And as this cools, more and more crystals will form. And I wish I could share this with you, but it is hotter, much hotter than it was when we started. And that's because, like I said, it's an exothermic reaction. So because it's an exothermic reaction, it produces its own heat when it goes through that chemical reaction. So because of this, this is also called hot ice. There are hand warmers that use this, and probably in like 30 minutes, in fact, here, now we can cool it down. Oops, whatever, let's just make a mess. I'll clean it up later. Towel. So, as we cool this down even more, it will solidify into a solid crystal structure and create a whole bunch of crystals. So yeah, this was something we've done in the past. Oh, and sure enough, more and more crystals are forming as we cool it down. Okay, it's like I know what I'm talking about. It's kind of hard to see on camera though. So, okay, our last experiment that we're going to do is we are going to just try to get this last can to go. So it's something we've already done. That's our 4 experiments. So again, just to recap, a lot of these things you can do at home. So the soy sauce in the water bottle, it looks like magic because it does. You can, if you're careful enough, it doesn't even look like you're doing anything. It just sinks right down the bottom. You want this as full as possible. So you want to take your water bottle and fill it all the way up to the cap, and then even more if you can. Like you want it maximum full, so there's barely any water. You can see that's. I have one tiny little bubble. That's all of my air. So the less air you can get in here, the more effective this will be. So We compressed air to make this magic rising soy sauce packet. We crushed a can using air pressure because we heated the water up inside it, which then filled it with water vapor or steam, same thing. And then we cooled it really rapidly. And when it rapidly cools, it compresses. If you use a more regular, this is like a tall can that is a little bit stronger. If you use a regular soda can, like a Coke can, this will work far better than it even worked here. It will like completely decimate your can. We also snuck some eggs in and out of a bottle using a air pressure and fire. So we reduced the amount of oxygen and in the container by burning it, and then that created a vacuum which pulled our egg in. And then we got it out by turning that same container upside down, creating a seal with our egg, and then and then we heated up the gas inside. And as we heated it up, it got more and more pressure behind the egg, and it pushed it out. And now we have an elongated egg. And then lastly, we looked at our sodium acetate, which is a super crystal former. And what we did is we boiled it, we heated it up to dissolve more and more crystals, and then we added a small little sprinkle of crystals into it in order to make those crystals start to form rapidly. Okay, so on to our last experiment. This should be hot enough now. Yeah, I think we're gonna, I'm hoping we get it this time. Here we go. Oh, a little bit. Not a lot though. The water just, oh wow, it's like suctioned to, that's hot. Hot things are hot. Newsflash. It like suctioned to the bottom of the container. But it collapsed it a little bit, not as much as I wanted. Like I said, regular cans work far better for this process. So if you have any questions, please feel free to ask. If you are watching from the middle school, please leave your name on your Google Classroom. And I'm looking forward to seeing you for our last week next week. So next week is the last week of Flagship Live. I hope you have a great rest of your day, and I'll see you later. Bye, everybody.